As I mentioned earlier, the signal in Figure 2 contains all the information at each point, such as amplitude, time, phase, and all the characteristic values. Therefore, we can perform wave height scanning. We can perform wave height scanning, which is a scan of the amplitude of the reflection wave to generate an image. At the same time, we can also conduct the time of flat scanning to generate an image. It's based on the time of flat between two signals. Reflection phase scanning is performed based on positive or negative phase for image. Additionally, we have a transmission probe placed here. We can scan in first image. So it is possible to perform T-scan. About tomo scan. Tomo refers to layered imaging similar to CT scan in medicine. For example, we can image the encapsulate and chip layer separately, or image the chip and the lead-free layer individually. We can scan hundreds of layers and image them separately. Since one scan, we can capture all the characteristic values of the entire wave only once. It's needed to complete all the scanning tasks. The scanning time can range from tens of seconds to several minutes, depending on the scanning modes and the complexity of the product. This method not only increases efficiency but also provides detailed internal structure information.